Okay, for today's video, we are looking at base E and natural logarithms. We'll talk about what that means here in just a second. But first, let's do a quick review from common logs and from using our calculator to solve log problems. So this first one, we would change it to log form because anytime you have an exponent that is a variable, you should probably change it to log form. So log base 6 of 8 equals 3x plus 1. So in my calculator, I'm going to do the log base button and do log in that little box of 6 and the big box of 8, and then I'm going to push enter and get a decimal. Now don't write that decimal number down, keep it in your calculator. So once you get that decimal, then you're going to hit -1, and it's going to do ANS -1, hit enter again, and then it's going to do divide by 3, and then once again it's going to do ANS divide by 3 and hit enter. And your answer should be 0.054. Okay, so try the same process with this next problem. You are going to have to use a square root button. See what you can do, and then pause it, give it a shot, and then check back. Okay, so hopefully you've attempted it. Your answer should be 2.378. And if you did not get that, you're welcome to come show me your calculator keystrokes, and I can help you figure out what you did wrong. This next one is definitely a challenge problem. It's pretty tough. Just give it a shot if you want. It's not something you would see on a test, but that is the answer in case you're curious. So, like I said, definitely not something you would see on on a test, but a challenge. Okay, so today we're going to look at natural logarithms, and we've talked about common logarithms yesterday. So common logarithms, remember, are just like if I said log of 4, it's assumed or understood that the base is 10. Okay. However, in science, in nature, there's another number that occurs more often than base 10, and they have called it E, and it's usually like kind of a cursive E. And E is a number 2.71828, and it goes on and on and on and on forever. So it's just a different base. So instead of saying like log base 10 or log base 3, this is log base E. Now, because it occurs so often and because it's a number used so much, they gave it its own notation, ln. Okay? Anytime you see ln, that stands for natural log, and it's assumed that the base is E. Okay, you have these buttons on your calculator. There's an ln button, and then if you second the ln button, it's an E to the x button. There's various reasons why they think it's ln and not nl. The original person who did this was French, and so it could have been that he notated like logarithm naturel instead of natural logarithms. There was also a guy named Napier who used to do science. He was like a math guy, and because his name was Napier, they speculated that he did ln, so it would be logarithm of Napier, like his logarithm to give him credit. So anyway, but it's ln, not nl. So to do these problems, they follow all the same rules as logs, except the base is just 2.71828, blah, 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 instead of being base 10 or base 5 or base 6. So in your calculator, to solve one like this, you would just hit the ln button and the 4. So ln 4, and you would get 1.386. To solve this next problem, you would use the second natural log button, which is the E to the x button. And so second natural log, and then you'd put 5 in for x, and you would get 148.413. So basically what you're saying is that 2.71828 goes on and on and on to the 5th power is 148.413. Okay. To solve this next one, I have a variable as an exponent, and what do we do when we have a variable as an exponent? We change it to log form, so natural log, base E, so I don't have to write base E because that's what the base is, of 5 equals x. So natural log of 5 is 1.609. Okay? Anytime the argument is an x, you change it to an exponent form. So base e to the 0.6931 power is 2.000 because it all rounds up. So that's what x is. Okay? So these next two problems are going to involve solving a little bit further, with a little bit more steps before we change forms. So if I want e to the x by itself, what should I do first? Add 7. Okay? So now I have 5e to the x equals 9. Now if I want e to the x by itself, next step, divide by 5. So e to the x equals 9/5. And you can change that to a decimal as long as it's not a repeating decimal. I'm going to leave it as a fraction. So now I need to change to log form. So natural log base e, I don't have to write that because that's what the base is of a natural log, of 9/5 equals x. Type that in my calculator, and I'm going to get 0.588. Remember, you can always plug this back in, check it, and make sure your work comes out. It might not be exact because you rounded the decimal, but it should be close. Okay, I'm going to let you try this next problem, so please push pause. Try this next problem, and then check back. Okay, so here is what I got for my answer. Check my work, check your work. I hope you got the same thing. Okay, and the last thing I want to look at is a word problem, and this is a different equation. A equals PE to the RT. P is like what was the little a before. It's the principal amount or the beginning amount, just like what the little a was in our last equation. E is, our new number we found, and R and T are still rate and time. So for this problem, P would be 1,000 because that's how much I started with. My rate would be 0.025 equals the rate, and the time equals T. Okay, so then I just plug everything in. So A equals 1,000, E 0.025 times 10. Okay, and when I type all that in my calculator, I get 1,284.03 cents. Now what that means is that if I put $1,000 in an account and the interest rate is 2.5% and it compounds continuously, after 10 years I would have gained an extra $284, so my new total would be $1,284.03. So the next question says, how long would it take to be $1,500? So in this case, now I'm solving for T. T is the thing I don't know. So 1,500 equals 1,000 E 0.025 T. Now, if you remember correctly, we could put this in y equals and do y1 and y2 and solve like we did before. However, now we know about logarithms, so I'm going to use it that way. So the first thing I'm going to do is divide by 1,000 because I want to get the variable by itself. So once I do that, I now have 1.5 equals e to the 0.025 t. Now it's ready to change to a log form. So because it's in base e, it's going to be a natural log, base e, of 1.5 equals 0.025 t. So I type natural log in the calculator, I divide it, so natural log of 1.5, push enter, and then push divide by 0.025. So t equals 16.219 years. Okay, this is probably one of my favorite units because the word problems are so real, because we do hopefully have money sometimes in savings accounts or in the bank, or we have loans that we're trying to pay, and so these equations are the ones that you'd actually use. I've actually gone into the bank with my calculator and looked when I was doing a car loan at the car dealership, and told them, nope, you're wrong with the interest rate. It shouldn't cost that much or whatever. And so it's important that these are the ones that you do use for that. So this is where logarithms come in, and this is some actual real life math that hopefully you'll use when you buy a car. So look at this one and be ready for 6-6 once you're done. Let me know if you have any questions. Bye guys.